Unit 5 was honestly like, as far as average percent on the test, was the best unit test of the semester. It's just, it's been a long time that we've done something with exponential functions, but you will see it for the next 2 years, so don't like completely forget it over the summer either. Unit 5 was our exponential functions. What's like the basic equation for our exponential functions? X squared is quadratic. So just like how you know linear is y equals mx plus b, you need to know that exponential is where x is the exponent. What is it usually attached to? What do we call the number that it's attached to? Well, there is a starting value, but it's not attached to the starting value. What is the exponent attached to? Anyone else? So we normally have an input and we normally have our output. Our output is equal to a times b to the x power is like the super simple one. A being initial amount, b being your common factor. So if it said that it was like doubling each time, you'd be times b by 2 each time, multiply by your factor. And then x would be the power, which is usually what's on the x-axis. Usually on the x-axis. Well, that too, but like what variable, like what in a situation is usually on the x-axis? I think someone said it. Time. Okay, so the exponent being x, like that's usually what it is, like our input. But also if you want to put t so that you remember it's the time, then that might be more helpful for our exponential functions. Now, notice in this first problem for unit 5, part 1, it says a car that was originally sold for 18,000 loses 1/5 of its value each year after it was bought. After 4 years, how much is the car worth? And then write an equation for the value of the car t years after it was selected. So let's see. Since we're losing by a ratio, which could also be like a percentage, if you will, I would recommend this equation for our exponential functions. The one where the b is plus or minus whatever the rate that is increasing or decreasing by. So these are both for exponential functions. Since we are talking about it losing 1/5 of its value, you don't multiply by what you're losing, you multiply by what you're keeping, remember? So I'm going to use this formula to help me set it up. If A is for initial amount, what's my A in this situation? 18,000. Is the car increasing or decreasing in value over time? So that's where I'm going to do the minus 1 minus the rate that it's decreasing by. Because it says it's losing 1/5. You don't multiply by what you're losing, you multiply by what you're keeping. This helps me figure out what I'm keeping. Do the t value. This was supposed to be in function notation. So I will write it in function notation. Instead of p, I'll put c. It might be fixed on your paper, but it's not fixed on mine. So I'll fix it. Future classes. Also, what is 1 minus 1/5? 4/5. Use calculator to do that. It is also a decimal that ends. 4/5 is 0.8. So like you would be allowed to leave it as a decimal. This would be the answer to number 2 on this question. The reason why I did this first is because now that I have my equation, then I would plug in the time, which is 4 years. I plug it in for t, and then that would give me the value of the car after 4 years. So here's me using function notation to show that I'm plugging it into function C before. I'm gonna use my calculator to calculate that. As you should, I don't think you can really do exponential functions by hand. And let the calculator do it for you. I know some people are gonna make this mistake where they do 18,000 times 4/5. And then square the 14,400. But really, you should be putting it all in at once, or at least do the exponents first. This is how much it's worth after 4 years. So it's originally about 18,000, now it's about 7,000. Since we're talking about money, how many decimal spots should I have? So if you need a round, make sure you round to 2 decimal spots. For this answer, I would put $7,372.80. Based on what my calculator said. So key thing here, multiply by what it's keeping. Or do the math, like make a table or something. But you don't multiply by what it's losing, you multiply by what it's keeping. Keeping 80% of it each day. So questions on that one? Okay, questions on others? Second one on unit 7. So unit 7, our more recent one, hopefully that's still fresh in your brain. It's solving, so it's not just, can I type it into Desmos and look at the x-axis, like the very first one will give you the x-intercepts and you will require you to show your steps by a specific method. The second one wants you to use any method. What method do you think would be easiest if it looks like this? The quadratic formula, I would agree, that one might be the easiest. We never taught you for when, to complete the square when A is not 1, and A is not 1 here, so you really can't use that one. I'm sure you could probably figure it out and then still do it, but like, I wouldn't recommend it. Factoring you can do. I think I did it in my 3rd hour, I can't remember, but you can watch the recordings and see if I solved it by factoring, it is possible. But quadratic formula might be the easiest because A is not 1, especially. What else? I will not make you memorize that formula again, so if you look up on the screen during your test tomorrow, it should be there, not just remind you. That's the only formula that I would give you. To use this, is it in the correct format? So it's in standard form set equal to 0, so I don't need to do any rearranging. I need to identify my A, B, and C. What's my A in this one? My B. -8, what's my C? So if it's negative, you need to show the negative. Usually we don't show if it's positive with a plus sign because it's assumed to be positive if it's not there. But if it's negative, you need to have it there. So then I plug it into this formula. Anytime you plug stuff in, use parentheses. I would not try to combine anything in this step, like I would just plug it in, exactly how it looks. Because the way that I see students not get the right answer is when they don't use parentheses. Use parentheses, the calculator will do it for you. Order of operations the right way. This is me plugging in based on the formula. Any questions? So then after that, I would start simplifying. So what happens with this double negative? Becomes a positive. What's under the square root symbol, I would just put that all in my calculator. I wouldn't try to do any of it myself. On the denominator, 2 times 3 is. So I just need to put what's under my square root symbol in the calculator. 1 second. So this is me putting what's under the square root symbol in the calculator.
It is so important. If you don't put the parentheses around this -8, it'll give you the wrong answer. So you have to do it. I don't know how many times I say it and people still don't listen. You have to do it. So under the square root symbol is the number 16. That is a perfect square. If you're not sure, because maybe you don't have it memorized, then test it out. The square root of 16 is 4, so I'll be replacing that little portion with a 4. Which makes this 8 plus or minus 4 over 6. From here is where I'd break it into the two problems where you're doing 8 plus 4 over 6 and 8 minus 4 over 6 because of that plus or minus. That's in the formula. What is 8 plus 4? What's 12 divided by 6? So one of my x's is 2. Over here, what's 8 minus 4? Over 6, what does that simplify to? 2/3. And guess what? If you are not good at simplifying your fractions, you just type it into Desmos like this. And press this little button. Now it gives me my simplified fraction, okay? So no excuses, but those are my two solutions using quadratic formula. You could do factoring too, but you would get those answers if you were right. Questions on that? If you do it by graphing, like say you completely forget how to do anything tomorrow, then it won't get you the full points, but if you could at least tell me what the solutions are at some points, I know you all know how to type into the Desmos and the x-axis. So I would at least get you some. Any other questions? Unit 6, number 1. So now we'll be seeing one from each unit, so that's the minimum requirement. You gotta do one from each unit at least. And you said the person? Okay. So the expression 16t squared represents the distance in feet an object falls after t seconds. The object is dropped from a height of 502. What is the height in feet of the object 5 seconds after it's dropped? And write an expression representing the height of the object in feet seconds after it is dropped. So you could use your critical thinking skills, just think about it logically. That'd probably be the easiest unless you remember a certain formula from that unit, which I'll remind you of in a minute, but really this could be done just using like your critical thinking skills. So if we're talking about an object falling and it tells you that this expression represents that, and we want to know what's the height of the object 5 seconds after it was dropped. Well, first I need to figure out how much it traveled. So I would plug 5 into the given expression. Use your calculator to solve that part, please. Sometimes I'd rather you do that instead of try things yourself. Because I know someone's going to do this tomorrow. They're going to do 16 times 5. And then they'll square the 80. And then here's what 80 squared is. Okay, that's not going to be the distance traveled. It wouldn't make sense when you go to do the next part either. What you have to do actually is the exponent first. So that's why I always say just let the calculator do order of operations for you. This is what it should be. 400 is what the object traveled in feet. Now that's not what it was asking. It said, what's the height of it? Well, if it started at 502 and it traveled 400, what should be my answer then? What math should I do to get this current? I should subtract. 502 minus 400, my starting height minus the distance fallen,
And what is the height? 100 feet. And that was all done without memorizing anything, just using what they already told you. For the writing the expression part, you can think about the math you did to do that. Which was basically take this expression and subtract it from the 502. Because it doesn't want just for a specific situation. It wants like for any amount of time. So that alone could be your answer. But what I mentioned about if you remember this from before, it might make it easier. We talked about how any sort of projectile motion problem was negative 16t squared plus the velocity times t plus your starting height. That was like our general setup for anything that's being thrown, dropped. It always follows that setup. So this part will be there because it is affected by gravity when you drop something. No velocity, they didn't say it was thrown at a rate of 8 feet per second or something like that. So no velocity term. Plus your starting height, which was 502. Either way that you write it, both would be correct. These are saying the same thing. It's just one requires you to memorize what we learned in that unit, which was that they all follow this setup. Or you could just use your critical thinking skills, whatever you do. Some questions on this one? Questions on others? Yes. So unit 6, part 2. It says use a diagram to show that 5x plus 2 times x plus 3 is equivalent to 5x squared plus 17x plus 6. When it says use a diagram, it's talking about this one. And since we have a 2-term by a 2-term, you would set it up like this, like a 2 by 2 box. If you showed me like by foiling and things like that could also show me that it's equivalent. But technically it said use a diagram, so I would just take off like a couple points for not doing that, but at least something's better than nothing. And it could be the extra credit that you decide. So if it's a 2-term by a 2-term, I'd set it up like this, where it's like each expression is on one side. So like 5x and 2, x and 3. So one expression on one side, the other expression on the other. If they were negative, make sure that you show that they happen to all be positive, so we don't usually write the positive. And then each individual box is like finding the area, so multiplying the dimension. What's 5x times x? 5x squared. What's 2 times x? What is 5x times 3? And then for this one, what's 2 times 3? And then when you combine like terms, we have a like term here and here. What's 15x plus 2x? That is a way that you can prove that it's equivalent to what it said it was, because it is. It didn't say, is it? It is equivalent, show it somehow that they're equivalent. Using the diagram would be this way. For the next part, it says, is x minus 3 in parentheses squared equivalent to 2x squared plus 6x plus 6? Explain or show your reasoning. So for part 2, it's not requiring you to make a diagram. Personally, I feel like since you would have to know how to make a diagram for the first part, we might as well do it for the second part. But there are other ways that you could explain it other than just that you multiplied it and got that, or didn't get that. But if I'm using a diagram, this is how I set it up. Always keep the sign that's in front of each term. I kind of skipped over this, but you need to remember that you're supposed to expand it. Like it's not just x squared minus 3 squared. It's x minus 3 times x minus 3. Set up your diagram, it should look like this. X's are positive, the 3's are negative. What's x times x? What's negative 3 times x? over here with -3 times x. And over here with -3 times -3. And when you combine like terms, the x squared does not have a like term. These two over here do, it's -3x plus -3x. -6x. And then plus 9, so 9 didn't have a like. So is it equivalent to 2x squared plus 6x plus 6? So make sure you answer that part. You would say no, it is not equivalent. And since I showed my work, that counts as explain or show your reasoning. I could just say that since I already showed my work. If you don't want to do the diagram, you could do foiling. You could say that you graphed both and they do not produce the same graph, like that would be okay, because it didn't say for that part that you had to do something specific. You just have to explain or show your reason. Any questions on that one? Right, might have time for one more. Justina? Unit 7, number 1. Okay, so that one is a bit of a pain just because it's not a pain for me because I know all my steps. I'm really good at memorizing steps. But I know like when I asked earlier, my other classes, they just completely forgot. This one tells you what the solutions are, so it's no secret that these are the solutions. They want you to show it by completing the square. Say you completely forget how to do that on the test. Use a different method, show all your work. It won't get you the full points, but at least that's better than no points, right? But by completing the square would get you full points. So is this in the right format for completing the square? Did I hear a yes or a no? It's not. How can I change it? What form is it supposed to be in? Good, I think you missed the first part. Did you say x squared plus bx? Yeah. Oh, okay. Good. Step 1 would be to rewrite it into this. For completing the square, it's the only one that doesn't want it set equal to 0 in standard form. It wants your constant term, the single number, to be on the other side. How do I move this to the other side? Subtract it, whatever you do on one side. Okay, make that a 5. But yeah, first step would be to rewrite it. If you want to look back at the lesson, it was lesson 12 that we did that. But I have x squared minus x equal to -5 over 36 when I do that. You wanted it to cancel over here. Whatever you do on one side, you do on the other. Questions on that so far? So then step 2 is to take half of b, so it's kind of a weird step, I know. You take half of b and then do what with it? Square it, then add to both sides. We went through in the lesson, why is that? So really now I just need you to memorize it, no matter how weird it is. We're gonna take half of b. What's my b value?
1.
Close. Not 0 either. Did I hear a 1?
Yeah.
Not 1. -1 is what b is. What's half of -1? Okay, -1/2 works. You could also say -0.5, but yes, -1/2 works. And then we're gonna square it. What's -1/2 squared? So for that one, since 0.5 is a decimal that ends, I would allow it. You just don't want to ever have to round too early. So if it's a decimal that ends, you can use it. But, or use a fraction. If I want to know what -1/2 squared is, how I type it in the calculator. If I want the fraction of it, I would press this button, and now it's a fraction. So 1/4, 4.25. So I'm gonna add that to both sides of this step. So it's gonna become x squared minus x plus 1/4 equals -5/36 plus 1/4. I know I have my calculator up, but I'll simplify that later. That was us adding it to both sides. For step 3, anyone remember what step 3 is? We factor the left side, because completing the square, what we want is to create something that when I set up my diamond, and have 1/4 on the top, -1 on the bottom. I want it to be the same number here and here, so that I could write it in the condensed format. That's what we mean by completing the square. And even though you might not like these numbers and they're kind of like not fun to work with, you should know what multiplies to 1/4 and adds to -1/2 because you did it in this step. It always was whatever half of b was. So if you try the -1/2 or the -0.5, whatever, that does give you 1/4, doesn't it? And doesn't it add to -1? So it shouldn't be that hard to figure out the numbers. You would have had to work with it earlier. And then you write it in its condensed form, x minus 1/2 in parentheses squared equal to, I'm now gonna add that side together. I skipped that for a second. So I can use my calculator to add it right now. Okay, if I want the fraction, which I should, because I don't want to have to round too early, I press that button and it tells me it's equal to lesson. Now from here, we are, if you look at the lesson 12, it's very specific. It'll tell you use square root both sides, solve for both cases. I shorten it to just isolate x. Start with what's farther, the bell will ring any second, but it rings stupidly. But you start with what's farther. What's the opposite of squaring something? Whatever you do on one side is the equal sign. So that becomes x minus 1/2. I can use my calculator to square root the 1/9 if I don't feel like doing it. It's not that hard, but I'll just use the calculator to show you it works. It's equal to plus or minus 1/3. Which then when I add 1/2 to both sides and then add it to the plus or minus 1/3, that's how I get my solution. If you watch the other recordings, I solved it in all of my classes, because it's pretty much the hardest one on there. Only because of the fraction. The steps are just straight memorization. And then you can use your calculator to do the fraction. So here I do positive 1/3. Plus 1/2. Which is how I get the 5/6. Right there. To get the other number they said was the solution, I would do the -1/3 plus 1/2, and that's how I get the 1/6. They told you what the answer is. So this is the cut. All right, any questions? So watch the videos, email me if you want to. Final exams tomorrow.